Welcome back. It's time to extract the train data and the test data. Lucky for us, there are built-in references that will help us achieve this. So, MNIST train, MNIST test equal MNIST dataset square brackets train, MNIST dataset square brackets test. But where is the validation dataset, you may ask? Don't worry, there's an explanation. By default, TensorFlow's MNIST has training and testing datasets, but no validation datasets. Sure, that's one of the more irritating properties of the TensorFlow datasets module, but in fact, it gives us the opportunity to actually practice splitting datasets on our own. Let's do it! As you can see, the train dataset is much bigger than the test one, so we'll take our validation data from the train dataset. The easiest way to do that? Take an arbitrary percentage of the train dataset to serve as validation. So, let's take 10% of it. We should start by setting the number of validation samples. Therefore, num validation samples equals 0.1 times the number of training samples. We can either count the number of training samples, or we can use the MNIST info variable we created earlier. I'd go for the latter, as it is readily available information. We can extract the number of samples by writing MNIST info splits train dot num examples. Okay, so we will get a number equal to the number of training samples divided by 10, right? We are not sure that this will be an integer, though. It may be 10000.2, which is not really a possible number of validation samples. To solve this issue effortlessly, we can overwrite the number of validation samples variable with tf cast number of validation samples tf int 64. This will cast the value of stored in the number of validation samples variable to an integer, thereby preventing any potential issues. Great! Now, let's also store the number of test samples in a dedicated variable. Note that we've got them in MNIST info. However, I'd prefer having easier access to this information. We can use the same approach and write num test samples equals MNIST info splits test num examples. Then, once more, we cast it to int64. All right. Normally, we would also like to scale our data in some way to make the result more numerically stable. In this case, we will simply prefer to have inputs between 0 and 1. With that said, let's define a function that will scale the inputs, called scale. It will take an MNIST image and its label. So, def scale with parameters, image and label. As a precaution, let's make sure all values are floats. So, we will cast the image local variable to a float 32. Next, we'll proceed by scaling it. As we already discussed, the MNIST images contain values from 0 to 255, representing the 256 shades of gray. Therefore, if we divide each element by 255, we'll get the desired result. All elements will be between 0 and 1. Therefore, image divided by equals 255 dot. The dot at the end once again signifies that we want a result to be a float. Finally, we have to return the image and the original label. So, this was a very specific function to write, right? In fact, there is a TensorFlow method called map which allows us to apply a custom transformation to a given dataset. Moreover, this map can only apply transformations that can take an input and a label and return an input and a label. That's why we build our scale function this way. Note that you can scale your data in other ways if you see fit. Just make sure that the function takes image and label and returns image and label. Thus, you are simply transforming the values. Okay, so how do we implement this for our problem? We've already decided we will take the validation data from MNIST train, so scale train and validation data equals MNIST train dot map of scale. This will scale the whole train dataset and store it in our new variable. Good job! For homework, you can try scaling the test data so it has the same scale as the train and validation data. Let's wrap it up here and continue with the pre-processing in the next lesson. Thanks for watching.